This is the screencast for section 2.1, example 8, exploring right and left hand limits. So we had a brief example in number 7, and now in number 8 we're going to dive right into left and right hand limits and function values at the same time. So we got this big old messy piecewise function that has a line with a negative slope between 0 and 1, a constant value of 1 between x values 1 and 2. It's defined just at x equals 2 as the dot at y equals 2, I guess, so this point appears 2, 2. Between 2 and 3, we've got a slope of positive 1, y-intercept, negative 1, linear function. And then another linear function between 3 and 4 with a negative slope and a y-intercept of 5. Okay. So let's look at this step by step. At x equals 0. So we'll look at what's going on here right at the beginning of this defined piecewise function. The limit as x approaches 0 from the right. See, now we can't do from the left or just as x approaches 0 because there's nothing on the left-hand side. So the limit as x approaches 0 from the right is going to be 1. Now off to the side here, I've asked you to define exactly what f of 0 is. F of 0, so the function's value at 0, is also 1. Now look at what's happening at x equals 1. At x equals 1, let's see, the limit as x approaches 1 from the left, the y values approach 0. But the limit as x approaches 1 from the right, the y values approach 1. So since the left and the right don't approach the same value, the limit as x approaches 1 of f of x does not exist. Now the actual function's value at 1, so the definition of f at 1 is 1. There is a solid dot at the y value 1. Now let's look at x equals 2. As x approaches 2 from the left, the y values approach 1. As x approaches 2 from the right, the y values also approach 1. So the limit as x approaches 2 in general, the two-sided limit does exist, and it is 1, because the limit as x approaches 2 from the left and right are the same exact value. Now, however, f of 2, so the function's value at 2, is 2. It's not 1. Basically, there was a removable discontinuity where it was defined elsewhere. So the limit as x approaches 2 is 1, but they fooled you, its actual value is 2. It's a discontinuity. At x equals 3. The limit as x approaches 3 from the left is 2. The limit as x approaches 3 from the right is also the y value 2. And the function's value at 3 is also 2. So the two-sided limit in this case does exist. And here's a heads up for you. Since the two-sided limit exists and the function is defined at that exact value, look how continuous this is. How continuous? It's continuous. Now looking at the right end here, the limit as x approaches 4 from the left is 1, and the function's value at 4 is also 1. Now this now try problem has the graph already done for you. They didn't really define the piecewise function, and they're just asking us to identify several limits. So here we go. The limit as x approaches 0 from the right. So if I follow the function and I approach the x value 0 from the right, the y values get very, very close to 0. Now, as you can see, the function's value at 0 is not 0, the function's value is 1, but the limit from the right is 0. Now, the limit as x approaches 0 from the left is also 0, which then means, since the limit from the right and the limit from the left are the same, that the two-sided limit as x approaches 0 of f of x is also 0. Now, looking at let's see, as x approaches negative 1 from the right. So as we follow the function from the right, the y values approach positive 1. Now the limit as x approaches positive 1 from the left, okay, following the function, the y values from the left approach positive 1. From the right, though, they approach 0. So the limit as x approaches 1, the two-sided limit does not exist because the left and the right do not approach the same thing. Now the limit as x approaches 2 from the left is 0. Number 51 asks us to draw the graph of f. Oh, piecewise function, here we go. So if my boundary is at x equals 2, on the left side of x equals 2, where x is less than 2, I have, let's see, a line whose slope is -1 and whose y-intercept is +3. So there's the y-intercept, and the slope is -1. So I'm going to go down 1, right 1, down 1, right 1. And it's not defined at x equals 2, so I'm going to have an open circle there, not a closed circle. But I get an idea of where this line should be going. Now to the right of 2, I have also a line whose slope is 1/2 and whose y-intercept is +1. Well, it's not drawn on the y-axis, so instead I'm going to plug in 2. Let's see, 2 over 2 is 1 plus 1 is 2. So the value at 2 should be 2. And then from there I can do my slope up 1, right 2, up 1, right 2, and kind of shortcut that process so I don't have to start over to the left of where the graph is actually drawn. I can start right at 2, find out what its value is. Again, open circle because x is not defined at 2. So now I've got my piecewise function. And part B asks to determine the limit as x approaches c from the right and the limit as x approaches c from the left. So part B, the limit as x approaches 2 from the right of f of x, let's see, 2 from the right is going to be 2. The limit as x approaches 2 from the left of f of x, so coming in from the left, we only approach 1. Now part C says, write to learn. Does the limit as x approaches c of f of x exist? If so, what is it? If not, explain. Since the limit as x approaches 2 from the left of f of x does not equal the limit of f of x as x approaches 2 from the right, comma, the limit as x approaches 2, so the two-sided limit of f of x does not exist.